This is mostly a general overview of Firebase. I don't think we'll be going too deep dive into anything specifically, although if that's something that your chapter is interested in, I'd be more than happy to deep dive into something like Cloud Firestore or the authentication, any one of the services. So without further ado, I'm going to share screen. Okay. So small, little bit about me. I used to be a GDSC lead, and then I graduated with a bachelor's of science in computer science, and then I have a minor in math and physics. I moved down to San Diego. I got a job as a software engineer, and I'm currently transitioning into running my own software consulting business. And at the same time, I joined the Google Developer Group of San Diego. So there's Google Developer Student Clubs. You have one, obviously, for Columbia University, but more than likely there are a number of Google Developer groups in your city. I would highly recommend to check them out. When you graduate, it's very hard to find communities that you can easily network and learn and grow. Google Developer Groups is great for that. You'll meet people of all different walks of life, different levels of experience, and a lot of it can be great to push you into the next, frontier of your personal and professional life. Professional being the real highlight of it. You'll get to meet people that you maybe might not otherwise have had access to. So for that reason, small plug GDGs. But after joining the GDG in San Diego, I became an organizer. I attended a few events for a couple months, and then I eventually became an organizer. And very recently, the lead stepped down, and I became the new lead for the Google Developer Group of San Diego. So if any one of you that are watching this later on or that are attending now would like to join the chapter, maybe, come to a few events virtually, we'd love to have you there. It's maybe a little bit higher level than GDSC, more deep dive into cloud and I would say maybe overarching projects. How do you do a web app with everything, with a custom backend, with serverless functions, with machine learning, data visualization tools, stuff like that. But for now, we'll just stick to Firebase. So again, this is just mostly an overview of Firebase. One thing I wanted to say for the guys of you watching live, I do have the chat opened up, but in case I do miss anything in the chat, just Derek, if you could Slack me, please feel free to ask questions as soon as I'm going over anything. I'll try to be quick with this. So if I'm going fast, just, shoot a message in the chat. Again, I'm sure most of you already know this, but just some basic terminology. We've got front end, we've got back end, and then you've got a tech stack that makes up your front, back, and other services that you have in a web, mobile, any service really. We've got an SDK, software development kit, and so we'll be talking about the Firebase SDK. CDNs is a content delivery network. Essentially what this is, it is hubs across the world that have pieces of your data, website, app cached, and it allows you to receive your website, your app, your data somewhere close to you. And then the last one is a CLI, command line interface, and the Firebase tools library is a CLI that allows you to interact with Firebase projects from your terminal, as well as do stuff like initialize a new project, set up emulators. Actually, I think I might have left emulators out of this presentation, but it is one of the true highlights of Firebase. So if I have left it out, I will make sure to touch on it. In general, Firebase, this is their mission on their website, is to help app developers succeed. Now, it's not only apps, although they focus majority on mobile apps, web has become a really large part of Firebase, and they've got a number of tools that are exclusive to both mobile and web. They're starting to bring some more exclusive to web. 3 tiers mostly to Firebase. The first one is their build tier. And this is in the process of building your app. And I think this is mostly what the people in your chapter will be using, since you guys are, still working towards finalizing your solution challenge project. Although, Alex mentioned he had a couple apps with a lot of users, and so he might be looking at tier 2 and 3 as well. But the core of these are, your authentication. How do you get people to log into your app? Hosting. If you've got a website, you want to have people access them. You don't want to have it sitting at home on your PC or Raspberry Pi. You can host things for free, might I add. Cloud functions. These are serverless functions. Serverless is just a fancy word for you don't need to have a full-time virtual computer in the cloud running. It will spin something up, compute what you need, and then shut down afterwards. In Firebase, they're completely free. Google Cloud does have an analogous called Cloud Run. A little bit more powerful, a little bit more customizable, but does have a fee associated with it. MLKit is really great if you're on mobile. You can use that to run lots of different types of machine learning, common machine learning, things. Let's just call them things, machine learning things, like image recognition, barcode scanning, language translation, text analysis, stuff like that. Cloud Firestore, I think, is the most prominent app of the build column. That's your NoSQL database. Right next door to it is the real-time database. Fun piece of history. Real-time database is actually the original Firebase. Firebase was just the real-time database. It was a NoSQL database, and it specialized in offline usage. So if you were running through a train or if you were on an airplane or something, they had the ability to do offline downloading and then re-uploading when you connect back to the internet. It's not as commonly used anymore, although they do keep it. It's somewhat been replaced by Cloud Firestore. We then have cloud storage, another great SDK. The cloud storage SDK is for any kind of file storage. So if you've got images, profile photos, for example, on a web app, and Google might give you their profile photo from their Google account, but if you want to be able to change that profile photo, cloud storage allows you to upload the photo, receive a downloadable link that then you can save into their user document in Cloud Firestore. The last one is extensions. This has had a revamp within the last couple months. Really great things are still to come, but this is for everything outside of the core Firebase services. And one example that I use daily is delete user data. If you delete a user that's in your authentication tab on Firebase, say they've authenticated with Firebase, and you have it linked to Cloud Firestore in such a way that your authentication ID is the user's document ID, think of it like a primary key, then when you delete a user from authentication, it will clear up all of the data within your database. Another extension, a very popular one I also use, is the trigger email. And so if you've got an email functionality within your app, say you want to send out newsletters, say you want to do a billing platform, and you want to send out invoices, these kinds of things can be done quite easily. You have a collection in Firestore, and the extension will allow you to send emails really simply. There's quite a few of extensions being built right now by the community. That's the big change. One quite popular one just released about 2 weeks ago is a PDF generator. Say, for example, you've got data in Cloud Firestore related to invoices. You can generate a PDF from that data in a matter of seconds, and then you can use the trigger email to send an email with the PDF. Really powerful stuff being done with extensions right now. The next one is to improve the quality of your websites and apps. If you've already got users, one thing you want to make sure never happens is crashes, but they obviously will happen. And so Crashlytics is kind of there to catch you. It is, for the time being, available only to apps. So the mobile SDK is the only one that works right now. It is still an amazing SDK. Anytime you have a crash, all that information will be sent to Firebase so that you can analyze it, see what device they were using, see what kind of stresses were on the system when it happened, what were they clicking, what were they doing. This will help you find those situations, those edge cases where things do go wrong, and then fix it. The second one is performance monitoring, and this is available on both web and mobile, although it is more prevalent in mobile. This is essentially your first loading. How long does it take for the user to click on the app icon and then get to some level of interactivity? In the web, this is called your first, your time to interactive, TTI. But it also measures stuff like your first contentful paint. How long does it take before the browser will render a usable screen, or something that looks like a usable screen at least? And then after that, we've got Test Lab. This is, again, only available to the mobile SDK. And it's a great way to run your tests virtually. And so it's got servers that allow you to write unit testing, integration testing, the full load of it. And custom building something like this is a very, very difficult thing to do. My roommate works for the testing team at a very large company, and they have spent tens, if not hundreds of thousands of engineer hours building testing systems. So having a SDK like this is really immeasurable. The last one is really fun. I've used it a lot. It's app distribution. If you've ever used the iOS Test Flight app, it's very similar. It allows you to basically download an app onto your phone and distribute apps to a whitelisted list of users. So you can get people's, I think it's SSID in their phone. I can't remember now. But anyways, it's a special type of key in their phone. They provide it to you, and you can distribute apps to them and have them test it out before you do a major release, say, for example. It's really cool too. And then the last column over here is, once you've built your app, once you've made sure that you've got all the infrastructure in place, that it's working correctly and as you expect it to, you want to grow. And this is where you've got analytics playing a massive role. Now, there is Google Analytics, as it was formerly known. It's been around for close to 15 years at this point. It's a very, very powerful tool. It has actually been moved into Firebase, and Firebase is now the home of Google Analytics. It's now Firebase Analytics. Extremely powerful. It allows you to determine where your users are coming from, not only geographically, but on the internet. Are they coming from social media posts you've made? Are they coming from different blog sites? Are they coming directly to your app? I think one of the most crucial ones, are they coming from advertisements? So if you've got something like Google ads or Facebook ads or LinkedIn ads, whatever it is that you're using, you can then put a value on those ads, the ad spend, tied to your return on investment through engagement on the site, all the way through, in fact, to what's called events, purchasing, cart checkout, add items to cart, the full load. You've then got, remote configuration options, somewhat niche, but somewhat fun. Remote configuration essentially allows you to send a discount to a user that is more likely to make a purchase. Say they've been on your app in the last week and they were looking at some shoes, but they didn't quite make the purchase. The next time they come onto the app, you can give them a 5, 10, 15% discount, for example, to encourage that purchase, or any other kind of conversion you're looking to target. Remote configuration is there to help you out with that. Predictions is very much tied to remote configuration. You will need to have predictions on in order to use remote configuration quite well. And the same thing as, we said that if a user comes on and they don't make a purchase, but they were looking, predictions will go a little bit deeper than that. Predictions might say that this user was looking at this shoe, but they might actually like this one as well. And so using predictions, analytics, and remote configuration, you can really tailor your user experience. A/B testing is kind of in the same vein, although it's a little bit more for experimentation on your end to see, whether a rounded button works better versus a square button, whether the green button works better than a blue button. And, this is really to gain that extra 1-2% engagement on your app or your website. Still a very fun feature. Cloud messaging. This is also one of those things that's very difficult to get done and to get done right. This is to send notifications to people. Very much similar to your in-app messaging. Cloud messaging will actually make a notification on the device. In-app messaging is more for, you have a new discount while they're on the app. So for example, you can have remote configuration trigger an in-app message for a discount on the shoe that they were looking at. Dynamic linking is also useful. It's a little bit less so. It's if you've got a website and you would like to have people click on a link on the website and it takes them directly to a specific page on the app, that's where you'll use dynamic linking. Most of the time, if you clicked on a link in a website, it'll say, open in app, and then it'll just take you to the home page. Dynamic linking allows you to take you from a website or anywhere else directly to the page you're looking for in app. And so the first, and I want to say maybe one of the most influential verticals is Firebase hosting. It's really, really fast, both to deploy and to download onto user devices. It's secured. You've got immediate SSL certification on your websites. It comes with a domain name. You can obviously attach a separate domain name if you would like, but it's already got SSL provisioning. So it's a really great free service. There's a global CDN, so it doesn't matter where your users are. They could be in Bangladesh and they can be in Ohio, and they'll get the exact same experience. And then, as I said, you can have a custom domain attached to that as well. This is also one of those that's basically every app there is needs it. You have to be able to log in and identify your users. And Firebase has got lots of different ways to authenticate, but some of the kind of cool ones that they have is the regular email and password, all of your most common OAuth, but they also have a phone number and text verification login, as well as one-time password, email verification. And here you can see that they've got, pretty wide selection of OAuth providers. I believe they've added a few in here, as well as I'm forgetting the name right now. I think it's OAuth 2. No, that's the service. There's the service with the star. I'm forgetting what it's called, but it's a popular open sourced version of authenticating. But you can use Facebook, GitHub, Google, Microsoft, Twitter, any of the popular OAuth login services. I think this is where I'd want to spend the most time. So if you guys have any questions in here, I'd love to go deep in it, because I've used Cloud Firestore really extensively. But high level, it can store and sync your data truly in real time. Cloud Firestore is built around gaming. And so if you've got, imagine a chess game, you want to have your ELO updated basically every move, especially if you've got something like bullet chess. And not only that, you want to have all the moves of the game synced every time it happens. So if you've got a chess match of a minute long, you could have 100 moves in there, more maybe. You want to have that updated really quickly, especially because it's time sensitive, or something like an FPS game. You want to have that data updated on all your devices really quickly. Firestore is great at that. Now, one of the contentious points about it is that it's a NoSQL document structure. It's different to this very structured query language that most people are used to and familiar with, right? There can be some drawbacks to this. One instance of that is if you've got 50 users in your users collection with a certain type of data payload, halfway through your development process, you decide you want to add some properties, and now the next 50% have got slightly more properties on their document than the other ones do. On the front end, if you're not handling those cases correctly, you could run into an instance where you're trying to access a property that doesn't exist. That's not possible in a SQL table, because you have to have everything kind of uniform in a SQL table. With that being said, it is free. Cloud Firestore is free and it's highly extensible. It's also great for prototyping. Very, very seldom do you have a really strict, solidified idea of what your app is going to do within the first year, 2, even 5 years, to be quite honest with you. So having the ability to change on the fly is great. I got a question from Alex. Do I believe this will be free long term? I do. And the reason I do is because Firebase has, for a while now, I think probably the reason Google bought it, been a gateway drug into Google Cloud Platform. There is a cloud version, a Google Cloud Platform version of Cloud Firestore that is slightly more available, a little bit higher availability, a little bit lower bandwidth, They do some extra things to keep their higher end clientele happy in the cloud platform. But the Firebase version is a gateway drug. They say, we've given you just enough to scale up to your first 10 million users. Once you get to the point where we've got more than 10 million users, we've got you covered in Google Cloud Platform. So for that reason, they try to keep most of their products in Firebase free. I put free with a little bit of an asterisk there. There is a pricing model. I don't believe I put the pricing model in this. I do have slides specifically for Cloud Firestore, and we do have the pricing model there. But it's something on the order of you get free like 500,000 document reads in a day, and or even closer to 1 million document reads in a day, and then like 500,000 document writes. So you can upload data 500,000 times in a day and download data 1 million times in a day before they'll charge you anything. And thereafter, I believe it's 0.02 cents per 100,000 reads. So it's like, in order to get anywhere close to being charged 10, or even $100 a month for something like Cloud Firestore, you have to have tens of millions of users on your app already, and they have to be using it quite significantly. So I wouldn't worry about the free tier of Cloud Firestore unless, I guess, in simpler terms, if you are worried about being charged, you've got a really good problem on your hands. So I guess that's what I'll say about the pricing model of Cloud Firestore. And truly, this is across Firebase in general. And then another one of the really popular features about Cloud Firestore is the offline handling and the auto scaling. Now, when you do get to 100, 200, 500,000 million documents, they've got what's called sharding. Sharding allows you to split your database somewhat. It reduces latency, and it sort of allows you to scale a bit better. But this is again on the Google Cloud network, and so they've got some serious infrastructure backing it. You'll never have to worry about scaling your database vertically or horizontally. If you've got your own custom servers running, you're going to have to worry about horizontally scaling in the best case scenario, vertically scaling in the worst case scenario. This does it all for you. You never have to worry about it. We spoke about this slightly. This is their real-time database. This is the OG Firebase. It looks a little bit more like a JSON tree. Now, Cloud Firestore also is, just really a fancy JSON tree. And it also does have real-time updates, offline handling, and present support. But I think that the latency on real-time database is slightly lower than it is on Cloud Firestore. This is from what I understand from the Firebase team, this is the core reason for using real-time database. It's truly for someone like a first-person shooter app. If they need, 100,000 uploads in a second, they can have that done quite easily in the real-time database. That's what they emphasize. For most people, I would recommend Cloud Firestore. They've got some more sophisticated technology surrounding Cloud Firestore that we'll speak about a little bit later. But nevertheless, if you do need that extremely low latency, the real-time database has got you covered there. Cloud storage, again, very similar to Cloud Firestore, really, really generous free tier. And the paid model is just as generous. It's quite substantial. But the primary usage of Cloud Firestore is for document uploading. So we gave an example earlier about having a user's profile photo on your website. Maybe you get an initial profile photo from their Google OAuth login, and they decide they want to change their profile photo to something else. You can upload to cloud storage, and then you can have a downloadable link that's then saved in Cloud Firestore. It is also cached, so you can have a really seamless experience for anyone, anywhere in the world. And it, again, like Cloud Firestore, will scale automatically. And I also want to have an emphasis that it's not just photos on here, documents as well. So if you've got an app that requires legal documents, you need to have PDFs uploaded and downloaded quite frequently. This handles that perfectly fine. It also does artifact management. So for example, if you've got a Docker image that you've built for a Golang or Python backend system, and you would like to have that, stored somewhere, you can do that in cloud storage. In fact, if you were using a service like Google Cloud Run, which is like Firebase functions, but a little bit more sophisticated, they will store those artifacts for you on cloud storage anyways. It's used quite frequently in what's called ML ops, machine learning ops. It's almost like DevOps, but for machine learning, where you will have a machine learning model built into an artifact. You'll have it stored in something like cloud storage. You'll then test it on, say, 0.2 of your total user base to make sure that your model has been successfully predicting what it's supposed to with the, whatever you deem to be a good, true, false, or true, positive, or whatever you're looking for. And then you can serve it out to the rest of your user base. But say, for example, you've tested it on that 0.2 and it's not doing so well. It's not predicting the way you expect it to. You can always roll back to an older version. And so you can have different versions of whatever artifact you're looking for. It's a great tool. Analytics is something that I think anybody who's looking to scale really needs. This is, I think, aside from Cloud Firestore and authentication, this is the SDK I use the most, because my goal is to know what users are doing on my site so that I can improve that aspect more than anything else. Performance monitoring is great for that too, but Google Analytics really helps you understand where your users are coming from, what they are doing, what they're spending the most time on, and then you tailor your app to their needs. At the end of the day, we build things that we enjoy, but we actually build them for other people to enjoy. And same like everything else, it's free and it's unlimited. You can gather whatever is allowed GDPR in consideration, but as much of it as you want. You can log every click on your app if you choose to do so, or you can just log every page that they navigate to. So it's very customizable. It's up to you, but whatever you do, it is free. Now, you do have some ability to do user segmentation and analysis on those. It's somewhat limited, especially nowadays with things like GDPR coming into effect. But a great example of this is to segment your users based on device. How many of your users are using a laptop versus an iPhone? How many of your users are using iOS versus Android, Safari versus Chrome? And this allows you to make certain strategic decisions. Maybe there's a library that doesn't work on Android, but it does work on iOS, and you know that 90% of your users are on iOS. It's something that you really need. You know that you got to cater towards the 90%. Or maybe it's the other way around. Regardless, it's good to have these insights. And then, again, this is this gateway drug coming into effect. You've got exporting of your analytics into Google Cloud's BigQuery platform. BigQuery is another one of the core tools in MLOps. So you can take a lot of these analytics, feed them into Google Cloud platform through BigQuery, and you can run machine learning on that data. So there is the Firebase predictions that we spoke about a little bit earlier that'll help you determine what products a user might be interested in, what services a user might be interested in. BigQuery allows you to, take the training wheels off a bit and customize your models to your needs. It could be making machine learning models. It could just be data visualization. So if you just want to visualize the data, say you've got stakeholders that are interested in knowing your user segmentation, and interested in knowing your engagement, your growth, you can export all this data into BigQuery on Google Cloud Platform. You can visualize it in a tool like Google's Data Studio. It'll bring up charts for you. You can put it into Google Sheets. There's a lot you can do with it. But again, this is one of the reasons Firebase is so cheap and in most cases free, is that they do have the ability to extend into some of the more niche paid services. These are really cool, and they are most powerful when used within a Firebase ecosystem. So these are not new. There is an analogous on all the major cloud service providers. In AWS, I know they're called Lambda functions. I'm not entirely certain what they are on Azure, but it's not a unique idea, let's call it. But where this comes into play is if you need some services that you can't provide on your client-side code, it has to be done by a more powerful machine, maybe, or a machine with different capabilities, different permissions, anything of the sorts. It can be quite expensive to run on a virtual machine. On Google Cloud, it's a compute instance, because you're paying essentially for 24 hours of uptime plus backups plus. So what they figured is, if you've got something, call it a price estimation tool. You've got some product and you're looking to do shipping, and you want to calculate how much shipping costs based on the weight, the distance between your nearest warehouse and the user. You could do it on the client side, but it maybe might make your bundle a little bit bigger, your initial load times a little bit slower. So you decide to go for something on a server, a little bit more powerful. It can do it in half a second or 0.1 of a second versus a whole second. They figured these operations last just a second, maybe 2, maybe 30 at the most. So why don't we allow users to write some code and upload them in a Dockerized version, because truly what this just is a Dockerized application of your code that will spin up an instance, perform the necessary calculations, and then shut down immediately after. If you've got a huge user base, you might have an uptime of, say, 12 hours instead of 24. Or if you've got an extraordinary user base, maybe you've got an uptime of just 23 compared to 24 hours. But at those levels, 1 hour difference makes a substantial financial impact. At the lower levels, obviously, if you've got architecture that's only being used 50 times a day, maybe, that is substantially cheaper than renting an entire compute instance for the whole day. So for that reason, I really highly recommend doing Cloud Functions. Whatever you can put on Cloud Functions, you should. It reduces your bundle time. The latency is very, very low. A little bit of an asterisk there. The first invocation of the instance takes slightly longer because you actually need to spin up and provide resources. I've got a great example of this I can share if anybody is interested. I built a very simple password generator using the big brother to Cloud Functions, Cloud Run. But it's the same principle. The very first invocation you make will take maybe a second or two. Thereafter, it's virtually instant. And then if you go away, have a cup of coffee and come back, that load time, the initial load time, will be somewhat slower. It's called a cold start. It is possible to get rid of the cold start, but you are then provisioning one machine to be up at all times. Another thing to mention on this cold start is you can choose to have just one machine up at all times. So that will take your first initial invocation. But it scales horizontally. Because it is a Dockerized application under the hood, it can scale virtually infinitely across different virtual machines. And both Google Cloud Run, the big brother to this, and Cloud Functions will do all of the load balancing for you. So if your first 100 users get routed to your first instance of this function, your 101st user might then get sent to a second instance of this Cloud Function. So if you had one virtual machine, you might do some calculations to say that maybe 1,000 users can access it at one time before you've got some race conditions happening and things don't work as planned. Cloud Functions scales to completely insane amounts that you'll never have to worry about a situation like that. In this slide, I've got deploys JS to the cloud JavaScript. Just about a week ago, maybe two, the Firebase team has released a beta release. Actually, I think it's still an alpha release for deploying Python in Cloud Functions 2. So there is the ability to do Python for Firebase Cloud Functions, as well as JavaScript. If you are looking to do something more sophisticated, maybe Java or Golang or C, C++, C#, you can use the big brother to Cloud Functions, Google Cloud Run. You can write whatever language you want, Dockerize it, and that will then be executed similarly to a Cloud Function. But these are somewhat nicer because they interact really, really well with your Firebase services. And so that's the type of event triggers that can invoke these Cloud Functions. You've got regular ones, an HTTP request. That's just a normal endpoint that you can hit, give it a payload, receive something back, done. But you can also have some more sophisticated transactions happen. I think I may have there we go. You can respond to events that happen in Firebase like authentication. I'll give you a great use case for this. Say you have a list of users that when they sign into the app must automatically receive admin permissions. So most users, they authenticate like normal and they're logged into the app and that's all good. But you've got a list of users that maybe get a special discount or admin permissions or whatever edge case needs to happen. You can listen to events on authentication, on signups or logins, and you can run a function based on that event to do any number of things. An example is update your database to include the admin permissions on their document. Really useful. The same thing is true for Cloud Firestore. Say, for example, a user has uploaded something to the invoices collection. I'm trying to think of a better example, but maybe it's something on invoices collection, and you then want to send an email out. So you can have a Cloud Function listen to changes on your database on Cloud Firestore, trigger an event, sends out an email. Same thing is true for analytics. Sorry, I'm also looking at the time. I can see that we're running over time here, and I apologize for that. And I have a question. Would this be applicable for session management? In other words, a user is only able to have one instance of the application at once. That's a good question. I'm assuming you're saying, if you've got a web app, you don't want to have them be able to have the web app open on their phone and on their mobile and on their tablet. Is that what you're looking for? I'm not entirely certain about that. I'm sure that there may be ways to get around it because there is definitely ways to block authentication from happening, both a sign up and a sign in. So say, for example, you have received a sign in from someone. You can then write that Cloud Function to say, when was the last time, this person was signed in and on what device? And I think from there, it may be a bit of a hack, but you could get it done. Theoretically, yes, I think you can get it done because you do have the ability to know when they're last logged in, and you do have the ability to prevent logins. So whether that means saving some property in the database or doing some kind of a workaround, it is possible. The last thing I want to mention is PubSub. PubSub is a publisher subscription service that Google offers in the Google Cloud Platform. You can work with those in Firebase, although Firebase doesn't have an analogous of PubSub. They just say to use the Google Cloud PubSub SDK itself. It's very much the same thing like a trigger. Something happens in one place, updates in another place. Here's an example. Say, for example, you're building a school app. A student submits something on Google Classroom. You want to have an update in your database to fetch the Google Classroom data and keep your database in sync. You can make a publisher in Google Classroom in your backend, and then you can subscribe to that somewhere else like a cloud function. We have another question similar as SQS SNS on Amazon. I'm not entirely certain. I haven't really played with AWS too much. I do know that the AWS version of Cloud Functions is Lambda. Now, if Lambda does have some extra functionalities like event triggers, then I guess, yes, it would be an analogous. We're almost at the end. I know that we're over time, and I apologize, but we're almost there. Firebase performance is a real quick one. As you can see on the images on the right, you can essentially tell what your latency is based on geographic location, device type. You can see how long it takes for your app to start up, to get active, to be for a page to load, for a button click to work. And this kind of data can be really useful if you, for example, see that a large group of people in Southeast Asia, for whatever reason, are struggling to reach this page. Maybe there's lower latency. Maybe there's a group in Ohio that's struggling to reach this page. Maybe it's because your database is situated in Europe. You can find this information out quite quickly using performance monitoring. You can also do any type of custom tracing that you would like. So how long does it take for your user to get from the home page to the setting page? Something like that. App distribution is great. You want to get your app out really quickly to a small subset of users to test out. App distribution is the one you're looking for. So it allows you to, I would say, build a MVP, get it in the hands of people to use and test, so you can find those edge cases where things break, where things are maybe not as usable as you thought that they were, without having to publish it on the App Store and be susceptible to negative reviews, because your app will live and die by its reviews on the App Store. So this way you get to iron out all the kinks before you publish it and get flooded by hateful messages on the App Store. And then on top of that, you get to collect all this data through Crashlytics and then iterate upon it really quite rapidly. And just as we've said, we've got Crashlytics for that. It's really instant. Now they do have it for web in a weird hack way. It's not as easy to implement, but for mobile, it's perfect. It will give you a snapshot of your user's instance, what version of iOS or Android they're running, what app version they had installed on their phone, what was their memory utilization, like lots of really, really cool metrics that you can take a look at, explore it, figure out what went wrong, why it went wrong, and then fix it. We spoke about cloud messaging a little bit in the beginning. It's, everybody gets them. They can be quite annoying, and they can also be quite useful. So you get those pop-ups that come in both within your app and when you're, not looking for them. And then you can also customize your notifications to a specific group. So maybe you want only your Android users to get a notification that a new app version is available, or maybe you want your iOS users to get a notification saying that they have a special discount. These are the kinds of things you can do with cloud messaging. It also gives you some engagement analytics about it. They're not great, but they do tell you how many people have opened it, how many people have led to a conversion because of that message. So you can essentially engineer your language around sending notifications to make them as useful as possible. I wanted to save the most important for last. In my mind, it's not the most important, but I know that it's definitely something that everybody's talking about today. And this is machine learning capabilities. Again, primarily for apps. There is some availability in web apps, but for mobile, it's quite prevalent. So you've got some on-device ML operations you can do, like facial recognition, I believe. You don't want that to go back to the cloud. So a lot of it you can't store, but you are able to use. You can do stuff like barcode scanning, for example. If you were to build a distribution center app, you can have custom barcodes made, and then you can have it be able to get scanned and linked to a special document in your database. It's really extensible. They've got out of the box machine learning operations, like I've just mentioned. They've also got some language models that you can use. But then you can also upload your own custom TensorFlow models if you choose. I believe they also are starting to allow PyTorch. But really, I mean, once you build it, it's all the same. You can upload your own custom models. And then, because again, this is tied to Google Cloud Platform, you can extend this in the Google Cloud Platform with their full AI suite. And I'm forgetting what the name of it's called Vertex AI. Vertex AI is the full machine learning and AI service for Google Cloud Platform. So this is the baby brother to that as well. So I guess with that, we're at the end. So yeah, once again, take a look at the full suite. There's some stuff I haven't talked about here, extensions being the one of them. Oh, lastly, I wanted to mention, and I'm really appalled at the fact that I did not include this in the slides. This is, in my opinion, one of the most, if not the most influential reasons to use Firebase. It is the emulator suite. Sorry, excuse me. You can have a locally emulated version of your entire Firebase project on your machine. This allows for extremely rapid iteration without having to have two separate instances of Firebase, one for testing, one for production. There is zero cost on any of the services unless you're using some external services in the Google Cloud Platform or something of that nature. But it's zero cost. So you can make a mistake in your database and read a million documents in the next 5 seconds, and you won't get charged a cent for it because it's all on your machine. It also allows you to import and export the data that you use. So say, for example, you've just started a web or mobile app. You've authenticated with a fake user. You've updated their profile with fake data. You've navigated around the app. You now close down your emulator. It will then save that data for you, which you can commit to a Git repository. And the next person who is making a branch from where you finished off, they can see that user you've added. So if you've got a team of 10 people, each one of them can build their own fake account, all commit to the same repository, and now you've got 10 fake users. The next time you can do another 10. All of a sudden, after a couple of weeks, you've got 100 fake users, and you can log in with different accounts, play around with it. You can even start up your emulators, import the data, and choose not to export it. So you can make some radically drastic breaking changes. And as soon as you shut down your emulator, it blows away completely. You never have to think about it ever again. It's super, super, super powerful. It allows for real rapid iteration without having to touch any of your production services ever. And I highly recommend it. It's a great experience. It really is. So I guess with that, we're pretty much done.